This is a Chapter 9 review. Give 4 polar ordered pairs for the given point. So here's the given point. Let's say point A. And we should, let's see, what's the radius? 1, 2, 3. The radius is 3. So we should be able to get 2 points with a positive 3 ordered pairs, and then 2 ordered pairs with a negative 3. All right, let's get to this point by going positive angle. That'd be 3 pi over 4. Then how about a negative angle? Negative 5 pi over 4. Then if we go in the negative direction, 1, 2, 3 here, make that a negative 3. Then when we get to this point, if you go negative 3, you're going up to that point A. Let's get to that point going negative angle. That's negative pi over 4. And then get to that point doing a positive angle, which is 7 pi over 4. Write the polar equation of the circle. Well, the circle has a radius of 2, so the equation is r equals 2. Give the polar equation of the line. Well, the line is on an angle of 5 pi over 12, so theta equals 5 pi over 12. So this would be the positive r's. This would be the negative r's. But we could also, now you don't have to write both of these, but we could also have theta equals 17 pi over 12. These would be the positive r's. That'd be the negative r's. Find the distance between point A and B. Well, this is the law of cosines. So the distance is the square root of 25, that's 5 squared, plus 36, that's 6 squared, minus 2 times 5 times 6, and then times the cosine of 135 minus 25. So we have square root of 25 plus 36 minus 2 times 5 times 6, and then cosine of 135 minus, not 6, minus 25. I'm going to make sure I'm in degrees, and the calculator's in degrees. So I have 9.029 rounded. 9.029 rounded. Anything down here? Nope. Give the polar form of the equation. Well, this is a cardioid, which means r at some point is going to be 0, which means we have r is equal to something plus or minus something. Now, since this bubbles to the left, the cosine, it affects the x. So I know that this is going to be a cosine of theta. Now, these two numbers need to be the same so that we can get a 0 for r. Those two numbers need to be the same, and they need to add to 6. So 3 minus 3 cosine of theta. Now, we could get a cardioid by 3 plus 3 cosine, but when theta is pi, the cosine needs to be negative 1. So we need a negative 1 there, in other words. So cosine of pi is negative 1. That gets you the 3 plus 3, because this value is going to be negative 1. This one's an inner circle, which means we're going to get a negative value. So r is equal to, this is going to be the smaller number. We're going to have a minus, a bigger number, and then sine of theta. Now, I know it's minus because it's bubbling out towards the negative sign. Let's see, when we add the two together, 10, 11, 12, it needs to add to 13, but 1, 2, 3, it needs to subtract to 3. So I think it's going to be 8 and 5. 5 here, 8 here. So that when we get sine of 3 pi over 2, that's negative 1. So you have a negative 8 times a negative 1 at 3 pi over 2. Well, that's going to give you the 5 plus 8. That's going to give you the 13. And then up here at the top at pi over 2, sine of pi over 2 is 1, and that's where you'll get the negative 3 down here. Excuse me. This one over here this is convex. Convex, so r is equal to something, and let's see, we're going 1, 2, 3. So The difference needs to be 3. And we have 1, 2, 3, 4, 5. And the sum needs to be 5. Difference 3, sum needs to be 5. So this has to be a 4. Now the bubble is going to the negative sign. So minus sine of theta. So 4 minus 1 is 3, and 4 plus 1 is 5. I mean, you're gonna get the plus 1 at sine of 3 pi over 2. Sine of 3 pi over 2, that's negative 1. So 4 minus negative 1, that's where you get the 5. Over here is dimpled. We have r is equal to, the two values need to add to 10 and subtract to 2. So we have a number and minus a number, and then cosine of theta. Two numbers that add to 10 but subtract to 2. Isn't it going to be 6 and 4? So 6 and 4. 6 and 4 add to 10. But over here, when cosine is 1, you're going to have 6 minus 4. Over here, cosine of 0 is 1. You're going to have a difference of 2. So the equation is r equals 6 minus 4 cosine of theta. Give the polar equation for each rose. The length of this petal is 4. So we have r is equal to 4. Since the petal does not start on the x-axis, this has to be a sine. 4 sine, and there are 1, 2, 3 petals. When there's an odd amount of petals, that's going to be the same value, 3 petals, same value for the coefficient of theta. So we have 3 theta. This one over here, the first petal starts on the x-axis. So we had to take the cosine of 0 as 1, and then 5 times 1 is 5. So this one's r equals 5 cosine. There are 1, 2, 3, 4 petals, which is an even amount of petals. Now to get an even amount of petals, you take the coefficient of theta and double that, and that's what should be 4. So this should be 2 theta. Give the polar equation of the circle. Well, the circle's off to the left. That means it's going to be a negative cosine. Now, the 0 to 3, that's the diameter. And so we have r is equal to negative 3 cosine of theta. This one is going up towards a positive sign. So the equation's r equals 5 sine of theta. So this number right here is always the diameter of the circle. If it goes up, it's positive, down, negative sign. Left is negative cosine, right is positive cosine, excuse me. Convert from polar to rectangular or rectangular to polar. So we have 520, this is the r, this is the theta, and we're converting this to rectangular. So we have 5 cosine of 20 degrees and 5 sine of 20 degrees. And if we can get the exact value, I want the exact value. Otherwise, we just use decimals. All right, I need to be in degrees. Got that. So 5 cosine of 20 degrees and 5 sine of 20 degrees. And so the answer here is 4.698 and 1.710. Over here, this to polar, so this is the x and this is the y. So the r, we needed r and a theta. R is square root of square 5 is 25. Square root of 2, that's times, not 4, but 2. Plus square 5 is 25. So square root of 50 plus 25, square root of 75, so 5 square root of 3. So there's the r, 5 square root of 3, and we need the theta. So inverse tangent of 5 over 5 square root of 2, which is 1 over square root of 2, and you can consider it as square root of 2 over 2, but so if it was inverse sine of square root of 2 over 2, this would be a pi over 4, but it doesn't work that way with tangent. So we want the inverse tangent of let's say 1 divided by square root of 2. That's not going to be nice. That's going to be 35.264 degrees. Convert the polar equation to rectangular. We have 3 equals, not 3 equals, r equals, I was thinking ahead, 3 over cosine of theta multiplied by cosine. R cosine is x, so x equals 3, and the graph is a line. R equals 3 cosine, we need to multiply both sides by r. This is x squared plus y squared, that's 3x. Subtract 3x over and complete the square. Plus something. 3 divided by 2, so b divided by 2 and then square that, that's 9/4. So we need to add 9/4 to both sides. So we get x minus 3/2 squared plus y squared is equal to 9/4. And this doesn't ask for it, but if it does on the test, that is a circle. Convert this to polar. We have x squared plus y squared minus 4y plus 4. That's expanding this out. It's equal to 4. We can minus 4 from both sides. X squared plus y squared is r squared. Minus 4r sine of theta. Y is r sine. Subtracting 4 and we get 0. So r squared equals 4r sine of theta. And we divide both sides by r. So we get 4, r equals 4 sine of theta, which is a circle.